Hi everyone, this is Mrs. J, and today we're going to be adding and subtracting rational expressions. Alright, to start I have a quick warm-up for you guys, so please pause the video and give it a try and then hit play when you're ready to check. Alright, let's check our work here. So for part A, again we can start by finding the LCD of their constant. So 3 and 5 gives us a common factor of 15. And then if we have x to the 8th and x to the 5th, the LCD is going to be x to the 8th because it's always going to be the larger power, so it works for both. So 15x to the 8th. For part B, you do need to factor your second denominator. And when you do that, you'll see that we actually have that common factor that we can cancel out. So that leaves us with only a single factor in our denominator here. So if we list out any factor we see within both denominators, it'd be x plus 3 times x minus 1. And this x minus 1 covers both. And for part C, again, we need to factor first. So we can factor the numerator with difference of 2 squares, the denominator with magic x. And here in our denominator, there's a GCF of -6. So here we have a common factor of x plus 4, so that cancels out. And then here we can cancel out the negatives. And then we just have a single factor on the left, x plus 3, and we have the factor of 6 on the right that we also need to include. So those are LCDs. If you need a quick review on how to do this, go ahead and rewatch the end of my last video, which is when I explained how to find the LCD of rational pairs. All right, so now we're going to be practicing adding and subtracting pairs of rational equations. So our one reminder for adding and subtracting fractions is that we must have a common denominator before we add or subtract. So to do that, we are going to be looking for an LCD and sometimes changing one or both of our fractions. So here we're going to add or subtract and then identify any excluded values and make sure we simplify. So in this first example, everything is already factored for us. So before we do anything else, we can list out any excluded values. So again, that's numbers that turn our denominator into 0. So both of these factors are the same, x plus 4, and they both tell us that x cannot equal -4. So that's our excluded value. And you'll also notice that our denominators are already the same. So if our denominators are the same, we can combine it into a single expression, and then we simply add the numerators. So it'll be 2x minus 3 plus 4x minus 5. And since we're simply adding the two expressions, we're really just combining like terms. So we can combine 2x and 4x to give us 6x. And then here we can combine -3 and -5 to give us -8. And then over x plus 4. And then just to see if we can simplify it all, we should factor our numerator. Our numerator does have a GCF of 2, so we can factor out that 2. So we get 2 times 3x minus 4 over x plus 4. So you can see here that there are no common factors to simplify. So we can leave our answer like this, or we could leave it multiply it out like the step above. Either one is fine. Okay, let's have a look at part B. So again, everything is factored. So we're ready to list our excluded values. So remember, you're essentially taking whatever you see in your denominator and you're saying that it cannot equal 0. And then we solve for x. So if we subtracted 3 and then divided by 2, we would get that x cannot equal -3 over 2. So there's our excluded value. And again, for this one, since the denominators are the same, we are ready to subtract. So we get a single expression over 2x plus 3. And we have x plus 12 minus 3x minus 2. And then the important thing to remember here is when you're subtracting a polynomial, you need to be careful that you distribute that negative, or that you're actually subtracting every term in the second polynomial. So this is actually x plus 12 minus 3x plus 2 over 2x plus 3. And now we can combine like terms. So this will leave us with negative 2x plus 14 over 2x plus 3. And again, we can factor our numerator just to check for any possible way to simplify. So we could factor out negative 2, and then that gives us x minus 7 over 2x plus 3. But you can see here that there are no common factors. So this is our simplified answer. Or again, you can leave the numerator multiplied out. So now we're going to practice adding and subtracting rational expressions that don't have the same denominator. So we're going to make sure to create that LCD before we add or subtract. So let's start by looking at this first example. So here we have 3 over 7 plus x plus 7 minus x over x. So we can start by listing our excluded values, just so we have those done. So again, if we take this and we say it cannot equal 0, that means that x cannot equal negative 7. And this tells us that x cannot equal 0. So there's our excluded values. And now we need to find a way to create our LCD. So for the LCD, again, we just need to include all factors that we see in the denominator. So the first factor that we can use is 7 plus x, or we can write it as x plus 7. And then we also have the factor x, which will be part of our LCD. So we cannot add these two expressions until both of our denominators have the same LCD. So this means that we are going to need to multiply both of our expressions to create that LCD before we add. So I'm going to rewrite our expressions again. So on the left side, we already have x plus 7 as part of our denominator, but we're missing x. So that's what we're going to multiply by in the numerator and denominator. Now on the right side, we already have x, but we're missing x plus 7. So that's what we're going to multiply by on the right side. All right, so now these two expressions have the same denominator, so that means that we can add the numerators. So our denominator is now x times x plus 7, and then our numerator becomes 3x plus 7 minus x times x plus 7. So here we are going to need to multiply out our numerator and combine like terms. So here this gives us 7x plus 49 minus x squared minus 7x over x times x plus 7. And then let's combine like terms. So we get negative x squared. You'll see that these two x terms cancel out, leaving us with just 3x plus 49. And all of that is over x times x plus 7. And here we could factor out the negative, but this trinomial is not factorable anyways. So that means that we are done because there's no way to simplify further. So there's our simplified answer. And again, our two excluded values are negative 7 and 0. All right, let's have a look at part B together. So here we do need to factor first before we start looking for excluded values. So here we cannot factor the numerator. It's 3x squared minus 1 over, and then we can factor the denominator using magic x. It'd be x minus 6 times x plus 3. Then we have minus x plus 2 over x minus 6. So let's take a moment and list out our excluded values real quick. This factor tells us that x cannot equal positive 6, because 6 would turn this factor to 0. And this tells us that x cannot equal negative 3. And then this factor is positive 6, which we already listed. So here are our two excluded values. And then before we subtract the two expressions, you'll notice that the denominators aren't the same. So we need to figure out what our LCD is. So our LCD is going to be x minus 6 times x plus 3. So both denominators need to be this exact expression before we can subtract. So actually the denominator on the left is ready to go, but the denominator on the right, we're missing x plus 3 as our factor. So we do need to multiply by x plus 3 in the numerator and the denominator. So now that the denominators are the same, we can add the two or subtract the two expressions. So that gives us 3x squared minus 1 in the numerator, and then minus x plus 2 times x plus 3. From here, it's just a matter of multiplying everything out. So the next thing I'm going to do is I'm going to multiply out these two binomials. I'm going to be really careful about this negative. So we're going to put whatever we get, the product, in parentheses. So it gives us 3x squared minus 1 minus x times x is x squared. And then here we have plus 3x plus 2x, which would give us plus 5x, and then plus 6. All over x minus 6 times x plus 3. And here we need to keep simplifying in the numerator. So we do need to remember to distribute that negative to all three terms. So this actually is 3x squared minus x squared, so that gives us 2x squared. And then we have minus 5x. And then here we have negative 1 minus 6, which is negative 7. And then times x minus 6 times x plus 3. And then our last step in simplifying is we do need to factor this numerator to make sure there's no common factors. So this is factorable. You can use that grouping method and you would get the two factors 2x minus 7 times x plus 1, and then it's over x minus 6 times x plus 3. So you can see here that there are no common factors, so that means that this was our simplified answer. So we can leave our answer factored like this, or we can leave it multiplied out like this. Either way is fine. But again, our two excluded values are listed up here, so we are all set. So again, start by factoring if you need to, list your excluded values, and then find what your LCD is so you can change your expressions if necessary before you add or subtract. All right, so I have two for you to try on your own. So please pause the video and give them a shot, and when you're ready, hit play to check your work. All right, go ahead and check your work. So for part A, the denominators are already the same, so this is a nice problem. Our one excluded value is that x cannot equal positive 5. Again, since the denominators are the same, we're ready to subtract the numerators. Just be careful that you distributed that negative. So you should get negative 15x minus 2, right? 5 minus 7 over x minus 5. And then here's our excluded value again. And then for part B, we do need to factor this denominator, so it becomes x minus 5 times x plus 3. So here we can list out our two excluded values, positive 5 and negative 3, and then we can determine our LCD. So our LCD is x minus 5 times x plus 3. So you can see that our second expression is missing x minus 5. So we have to multiply in the numerator and denominator by x minus 5. And then we're ready to add the numerators. So from here, it's just a matter of distributing and combining like terms. And then here our numerator is not factorable, so there is no way to simplify further. All right, We're going to try 2 more together. So here, again, we're going to follow that same process. We're going to factor, we're going to look for excluded values, and then we're going to add or subtract. So in the first example, the numerator here is not factorable. So we'll leave it like this. And then our denominator is x squared. And then on the right, we do have a GCF of x, so we can say x times x plus 1. Now, before we start canceling anything out, which I actually won't do in this problem because of what the LCD is, let's list out any excluded values. So this factor of x squared gives us the excluded value of 0, which also covers this factor of x. And this factor of x plus 1 gives us the excluded value of -1. So if we look at what the LCD of these two expressions are, we can see that our LCD is going to be x squared, so it's always going to be the larger power of any factor, times x plus 1. So we actually are not going to cancel out a common factor here because we're just going to multiply it right back in, so there's no use there. I also want to point out that these we cannot cancel out because this x squared is part of a larger expression. So you can't just cancel out a part of an expression. So please do not cancel out these x squares. They are not common factors. All right, so let's look at what's missing from each denominator. So on the left, we have x squared, but we're missing x plus 1. So we do need to multiply by x plus 1 in the denominator and the numerator. And then on the right side, we have 1 power of x and we have x plus 1, but we would like it to be x squared. So we do need to multiply by an additional power of x to create x squared. So now our denominators are both the same, which means we're ready to add our numerators. So we have x plus 1 times x squared plus 4x plus 2 plus x squared times x is x cubed, and all of that is over x squared times x plus 1. So from here, it's just a matter of multiplying out these two expressions next so we can combine like terms. So this gives us x cubed, and then we have plus 4x squared plus 2x plus x squared plus 4x plus 2, and then we have the plus x cubed here. And now let's just combine like terms. So I see x cubed and x cubed, so that gives us 2x cubed. And then we have 4x squared plus x squared, which leaves us with 5x squared. And then we have 2x and 4x, which leaves us with 6x. And then we have plus 2 over x squared times x plus 1. And since there's no way to factor this, we are done simplifying. And again, our excluded values are already listed up here at the top. So this one, I know it seems a little bit tedious to have to multiply this out just so we can combine like terms, but I do recommend just taking that step and actually writing it out before you combine like terms, because that's how you avoid small mistakes, and it really doesn't take that much longer to do. All right, we're going to try one more together. So this is kind of a challenge problem because here we actually have 3 different fractions, so we have to make sure that all 3 denominators are the same. So let's start by factoring our denominator here. So this gives us, this one will stay the same, x minus 2 times x plus 2. I'm going to leave myself some space. And then we have plus 1 over x plus 2 times x minus 2. That's difference of 2 squares. Now here, we have the factor, I'll leave the numerator as x plus 1 or x plus 2. But here our factor in the denominator is 2 minus x. So unfortunately that's not quite the same as x minus 2. However, if you ever see that you have a factor that is really close to another factor but it's simply opposites, meaning both values are opposite, I have a little trick for you guys. Here we can actually factor out a negative. So here's our minus sign. We'll factor out a negative right here, and then this becomes negative 2, and this becomes positive x. So it becomes x minus 2. So again, by factoring out that negative, I was able to change the sign of both of the terms inside so it matched these. And then here, since we have a negative in the denominator, we can actually just move it right out front, and then we can change this to a plus. So then they both become pluses. So now this entire expression, this last term, is going to be added, again, because we factored out that negative. And we just did that because we noticed that we wanted to create that LCD. So there's a little trick for you guys. So now we can list out our excluded values. So I can see from this factor that x cannot be negative 2. Negative 2 is already covered, and then x cannot be positive 2. And again, positive 2 is already covered here. So there's our excluded values. And now we need to figure out what our LCD is. So we need to list out any factor that we see in our denominator. So we see x plus 2 and x minus 2. So now we need to go through and multiply by whatever is missing. So in this first term we have x plus 2, but we're missing x minus 2. So that's what we'll multiply by the top and bottom. In our second expression, we actually have both factors, so we're ready to go. And then in our third one, we have x minus 2, but we're missing x plus 2. So that's what we'll multiply by. So now that we have our LCD, we're ready to add our numerators. So it leaves us with x minus 2 times x minus 2 plus 1 plus x plus 2 times x plus 2 all over x minus 2 times x plus 2. So now here's the kind of tedious part. We do need to start multiplying out our numerator so we can combine like terms. So here this gives us x squared, and then we have minus 2x, which gives us minus 4x, and then plus 4, negative 2 times negative 2. And then we have our plus 1, and then we have, again, x squared, and then this will give us 2x plus 2x, so plus 4x, and then plus 4. And all of this is over x minus 2 times x plus 2 still. And now we're going to look for ways that we can combine like terms. So we can combine our x squared terms. So that gives us 2x squared. You'll notice here that negative 4x and positive 4x cancel out. And then all we have left is 4 plus 1 plus 4, which is 9. So 2x squared plus 9 over x minus 2 times x plus 2. And since our numerator cannot be factored, there's no way to simplify this more. So we are all set. All right, so my advice for you guys with these problems is to just take your time. Although they are a little bit time consuming and they can seem a little bit tedious, if you keep your steps organized, none of the steps are actually too difficult. It's mostly just multiplying out polynomials and combining like terms. So just take your time and show every step, and you should be good to go. All right, here's the last two of the video. So please pause the video and give them a try on your own, and we will check your answers in just a few seconds. Okay, go ahead and check your work here. So for part 1, first you need to factor, and then this helps us list our restrictions, which are negative 5, positive 5, and negative 2. Then here you can see our LCD. So our first expression was missing x plus 2. Our second expression was missing x plus 5. And then once the denominators are the same, we just need to add the numerators. So from here on down, it's just a matter of distributing and combining like terms to get your final answer. And then for the second example, again, we do need to factor. So this gives us the restrictions that x cannot equal 0 or 5. And this gives us 0, so it's already covered. And then our LCD is going to be x squared. Make sure you have x squared so it works for both sides, times x minus 5. So our left side, we're actually missing 1 power of x, so we need to multiply by x over x. And then on the right side, we're missing x minus 5. And then here, we're ready to subtract. So from here, it's just a lot of multiplying out, and we do need to be careful to maintain this negative. So the first thing I did was I multiplied back out what I factored in that first step. So x plus 4 times x minus 1 is x squared plus 3x minus 4. And then in the next step, I multiplied these two polynomials out. Notice that I kept my result in parentheses because we still have that negative that needs to be distributed to all of the terms. So then our last step will be to distribute that negative. So it's actually 2x cubed minus x cubed, and then plus 2x squared plus 19x minus 20. So there's our simplified answer. All right, thank you guys for watching. That's it for today's video. I hope you all have a great day.